All right, we are continuing lesson 1.1 from our notes. You can see here we have example 5. We have two graphs here. If we flip the page over, it asks us what is the y-intercept for each graph. We'll do the first one first. We want to know the y-intercept and the slope. So we can figure that out here. Who can tell me the y-intercept for this graph? What is the y-intercept? Stefan. 20, yes. What, more specifically, what would I say? I could say y equals 20, right? Yeah, y equals 20. Y equals 20. Or actually, we would probably just say b equals 20, right? B, because we know b is the y-intercept. So let's say b equals 20. And for this graph, or actually we'll continue with this, what's the slope of this graph here? Rudy? Sorry? Is it 10x? Would you write 10x? What would you write for the slope? You're right, I'm not trying to trick you. You are kind of right. It wouldn't be 10x, it would just be 10. You got it. Yeah. Excellent. So therefore we know our equation is y equals 10x plus 20. Okay? Next one. Y-intercept of this graph over here. Yeah? Negative 3. Excellent. So I'm going to write b equals negative 3. And my slope is m. We're going to write m equals, Josiah, what's the slope of this graph? Josiah, sure. Go ahead. This graph right here. That's the equation of the line. What's the slope? Nope. That's the y-intercept. What's the slope? Josiah, in an equation of a line y equals mx plus b, what's the slope in that equation? What variable? Yeah, m. So what's m here? Say it again, louder. No, that's not m. Oh, it looks like it. The point there, they called it m. I have no idea why. But the slope is m, right? It's right here in this equation. What is it?
1/4?
Yeah, not positive 1/4, but? Right, okay. Okay, so the equation for this line, if that's the y-intercept, right, and that is the slope, Teodi, what's the equation of the line? Oh, sorry, Adrian, my bad.
Y equals negative 1/4x plus negative 3.
Plus negative 3 or?
Minus 3.
Minus 3. Because that's where he sits. You know that, right? That's where Teodi was sitting. Not because you look like him.
Good.
It's because that's where he sat yesterday. Yeah.
It wouldn't really matter what the negative sign is, right?
Here?
For the fraction. What do you mean?
It doesn't matter. You could put it on the numerator, you could put it in the middle, you could put it on the denominator. Denominator would look really weird. But you're right. If you guys want to be kind of more proper, yeah, you should maybe put it out front. It wouldn't matter though, to be totally honest with you. All right, next one. To determine the equation of a line from a graph. 1, you're going to find the value of the y-intercept b, determine the slope of the line m. How do we do this? How do we determine the slope? Slope is equal to what? Always the same guy here. Liam. Good. Which is equal to, was that Liam? Is that you? Yeah. Oh, it didn't sound like you. Okay, what's the formula for rise over run, Lucas?
Y2 minus y1 over x2 minus x1.
Good. Okay, and then how do we know what y2 is and y1 and x2 and x1? How do we know what those are, Alan? Yeah, not on the graph, but on the
The line.
on the line on the graph. Yeah. And which points do you pick if you're doing it? Jeds? What 2 points would you pick? What? You're right, any 2 points, but if you had a choice? Yeah. Why would you pick that? Easiest. Okay. Good job. Good job, guys. Substitute the values of m and b into the formula y equals mx plus b. All right, here we go. We are graphing. Graph a line. It says y equals negative 4 over 3, 7, x plus 2. So here we know the slope is what, RC? What's the slope? Yep. What's the rise, Rudy? If that's the slope, negative 4 over 7, what would be the rise? Remember, the slope is the rise over the run. Rudy, what's the rise?
You didn't rise over running to height?
Say it again.
I didn't know that you could rise over.
310.
I can't hear you. Say it again.
So, negative 4 would be the rise and then 7 would be the run.
Yeah, so if this is the slope, right, negative 4 over 7, we know it's equal to rise over run. What would be considered the rise then?
Negative 4,
Yeah, negative 4. Yeah, not a trick question. And the run?
7.
Good. Okay. Now the reason we're breaking these two values out is because we're going to use them now when we actually draw it. All we need here is the y-intercept, which we have is what? Engineer? 2. Positive 2, right? So we know our y-intercept is positive 2, so we know that this is a point on our line. Now watch how easy this is to graph. Instead of plugging in values here and creating a table of values, and I plug in a value for y and I find x and do all that stuff, I can just use the slope of the line. Okay? I know it's a straight line because I have my formula. I know I'm going to rise negative 4 and run 7. Okay, so that means I need to go down 4, 1, 2, 3, 4, because I'm going down negative, right? And then 7, I need to go positive to the right, 7. So I'm going to go down 4, 1, 2, 3, 4, and 7 to the right, all the way over here. Okay, so that is my line. Right there. Does that make sense to everybody? See how fast I did that? Even with your help, it took us like 2 minutes, and we graphed this to here. Amazing. Now you might have wrote this like this. Okay, I actually told you a little bit earlier that negative sign could actually go with the denominator, right? I said it looks weird, but I said there would have been no difference if you had wrote it like that. Okay. Now watch what happens if I go to try and graph this. Am I going to get the same line or a different line? There's a lot of controversy here. Let's find out. So I'm going to start at the same point because that's the y-intercept, but this time my rise is going to be plus 4. So I'm going to go 1, 2, 3, 4 up to 6, but my run is going to be negative. So I'm going to come all the way over to negative 7 and check it out. Magic. It's the same line. Okay? So that negative sign you could have put on the numerator, you could put it on the denominator. Okay, I prefer to deal with it on the numerator, but it wouldn't have made a difference. Now, the important takeaway too is that if your graph looked anything like this or like this, you know that these two lines have what kind of slope, RC? These two lines, this line and this line, have what kind of slope? No? Yeah, positive. I don't know if someone whispered that, but yeah, if they're going up, they're positive, right? They're going down, they're negative. Okay? What's the slope of this line, Jaden? Is it? You sure? It's not actually undefined. It's perfectly defined. It's 0. Okay? Now the reason we know the horizontal line is 0 and the vertical line is undefined is because it's rise over run. So when we have a horizontal line, it's not rising at all. So the rise is 0. The numerator is 0. Does that make sense? When it's a undefined line, It's the run that is 0. So you can't divide by 0. So that's what makes it undefined. So this m is equal to 0. This m is equal to question mark undefined or NA. Okay? You wouldn't say question mark because that's I don't know, but you would say undefined or not applicable. All right? Any questions with that one? All right, let's go. We got a few more, and then we're gonna look at some Khan Academy. Linear systems, solving by graphing. A linear system is a set of two or more linear relations considered at the same time. So basically, linear system, very fancy word of saying two lines. That's all it is, 2 lines. To solve the linear system is to find a point or points that satisfy all the equations of the system. So it sounds like, oh, let's solve the linear system. That sounds all very complicated, but all you're looking for is the point of intersection. That's it. That's the solution to the 2 lines, the linear system, right where they cross.
Sir,
Yep.
to have a point of intersection, one line must be negative, right?
Yeah, exactly. No, not necessarily. You could have 2 lines that are like this. I'm trying not to mess up our page, but you could have a line like this, and you could have a line like this. In which case, both slopes are positive. Okay? So you don't have to have one to be negative. In this case, one is. They make a nice looking X. One is negative, one is positive, but you don't need to. All right, its coordinates satisfy both equations. So what does that mean? That's just a fancy way of saying that its coordinate intersection, its point lies on both lines, right? It's on this line and it's on this line, okay? So if a point lies on the line, it's going to satisfy the equation of the line, all right? So what are the coordinates of the point of intersection of each linear system? This is really easy to do. What's that point, Douglas?
3 and 2.
Excellent. 3 and 2. Okay, you put them in brackets. Josiah, what's that point?
Me or Josiah?
Josiah. -1, yeah, and 4. Good. Now, if you cannot read one of these graphs, you're going to have to practice. Okay? If you're having trouble with this, like which number comes first, just use the alphabet, X before Y. If you can't remember if X runs this way or this way, you really have to try to remember, you really have to review that. You just practice. Okay? Because if you can't read where the point is, you can do everything right, do all the work, and then you can't read the answer, and you're not going to get the marks. Okay? All right. A linear system can be solved graphically and algebraically. So we can either solve it like this. This is solved graphically. That's the solution. Or we can do it using algebra. We don't even have to graph it. Now, I prefer algebra. Some of you might say, well, I hate algebra. Algebra is a lot easier because you don't have to be such an artiste. You don't got to be so artistic. You can just do it all with the numbers. Okay? So we're going to see that here now. It says, solve the linear system graphically. Check your solution in both equations. Okay, so we're going to solve it with a graph, and then to check the solution, that is a fancy way of, that means take the point of intersection, plug it into both formulas, and if they give you a nice equal sign on both sides of the equal, if it's equal on both sides of the equal sign, then you know that that point satisfies both equations. All right, so that's what we'll do. All right, we're going to do it the quick way that we did on the last graph. This one, what is my slope here, Rudy, for this one? What's the formula for slope? Rudy? The formula for slope. I couldn't hear. I'm asking Rudy. He knows it. What is it? M equals? You're right, the slope is 2, but I'm asking the formula for the slope. Like how do you get it? What is it? No, that's the equation of line. RC, help him out. What's the formula for slope?
Rise over run.
Yeah, rise over run, right? And the more complicated version of that is y2 minus y1 minus. Oh, remember this, Rudy? Sorry?
was doing the grass and green, now I'm doing the grass and green.
Yeah, but we just did it, bro. We just did it right here. We just did this, right?
Wow.
You don't understand this?
I learned the other way. I learned the other way.
This y2 minus y1,
Yeah.
x2. Okay, they're the same thing. When you're minusing the y values, you're getting the rise. Okay. When you're minusing the x values, you're getting the run. Okay. You got to know both of them. All right. For grade 10, you need to know both. All right. So all I wanted to hear was rise over run. Now I did that for a reason. I wasn't trying to just pick on you there. I wanted to ask that because I know you know the slope is 2, but how would you write it if you wanted to write it rise over run? Alan. 1 over 2. Ooh, that wouldn't work. Two over 2 wouldn't work either. How about Lucas?
Where y equals
What?
run y equals where equals 7,
Yeah.
2 over 1.
Yeah, 2 over 1. Everybody understand that. I want everyone to understand. Why am I writing the 2 as 2 over 1? Yeah, Adrian?
Because 2 over 1 equals 3.
Yeah, 2 over 1 equals 2. But you guys know why I'm writing it like that? For this particular case? Yeah, Lucas?
It's already like the final.
Yeah, because what I want to do, I don't know if that's the reason, but here's what I want to do. I'm going to have y equals 7, right? This is my y-intercept. It's up here. Okay, I know that from the 7. But what I want to do now is I want to do the little pattern that I did before, where I rise 2 and I run 1. So I'm going to go 1, 2, and run 1 here. Okay? That's why I wrote the 2 over 1, just so you knew what I need to run, like what I need to move horizontally. So up 2 over 1. Does that make sense to you guys? If you just see one number there, it might be confusing, right? You're not going to know how to graph it. Now you know.
Wait, so any just one number is over 1?
Yes, exactly. That's my point. Good, RC. All right, the next one. What is the slope for this? Douglas.
0.5 over 1.
Okay, I don't like that. You're right. You're not wrong, but I don't like that. Let's see if we can have a better version of that. Milky.
1 over 2.
1 over 2. Beautiful. Now, why do I prefer 1 over 2 instead of 0.5 over 1? Yeah? Sorry?
So that's a 1.
Yeah, it's rise over run. It's just easier to visualize. You could rise 0.5 and you could run 1, but it's just going to be harder to graph that way. Do you understand? Okay, so that's my slope there, and I know my y-intercept, which we call b, is equal to 4. So in this case, I know I'm starting here, 4. Okay, and I'm rising 1, and I'm running 2. 1, 2. So it's here and here. So this is my line. Okay. Now, I am not a great drawer. Clearly, I teach math, not art, but I'm going to try. Now, this is why I prefer algebra, okay? Look at where these cross. It's not that easy here. It looks like 2.5 minus 3, 2.5. That would be my guess. Minus 3, 2.5. That's where it looks like it crosses. Okay. Now, if I were to have drawn this with a ruler perfectly, I would be a lot more confident in that point there. I'm going to guess here. This point is minus 3, 2.5. That's my guess. Okay. But I'm actually going to solve it algebraically now, because it says check your solution in both equations. So one way to check would to be sub this into here, and we will check. Let's do that right now. Okay, so I'm just going to erase this to give me a bit more space. put it up here. B equals 7. Okay, so let's check this. I actually think it's going to be wrong, but let's check. So instead of 2.5, I'm actually going to use 3 over 2. No, not 3 over 2. I'm going to use 7. Hold on. 2.5.
Sorry.
I'm going to use 5 over 2. Yep.
So it's okay that I got something negative, right?
Yeah, we're gonna get the answer here. Just hold on, okay? So I'm gonna use 5 over 2 and negative 3. So y. So here my solution or point of intersection. Okay, they're the same thing. From graph is equal to now negative 3, 5 over 2. Okay, does everyone know how to convert 2.5 from a decimal to a fraction, 5 over 2? You could just write it out like this, 2.5. Multiply the 2 by the denominator, you get 4. Add the 1 is 5 over 2. Okay? Now, I did that on purpose because I'm going to do this by hand. If I had a calculator, I might leave it at 2.5 as a decimal. But let's just do this. Now, I'm going ahead with this. I'm pretty sure this is wrong. We're going to find out though. But let's see, okay? So my x value is 3 and my y value is 5 over 2. So I'm going to plug that into the equation of the line, which is this. Okay? So in order, that's this line, remember? This line up here, this is y equals 2x plus 7. And this line down here is y equals 1/2 x plus 4. Those are my two lines. Now, if I plug this value in and I get equal on both sides, that means that this point is on this line. Does anyone have any questions with that? You guys get that, right?
Yes, sir. You would plug it in the x value.
Yeah, I'm going to plug in this for x and this for y. Okay, so let's go ahead and do it. You need to know why we're doing this though, right? So I'm telling you why. If I plug it in and I get equal on both sides, that means that this point is on this line. So let's see what happens here. I get 5 over 2 minus 7 equals negative 6. Okay, so we get 5 minus 14 over 2 equals negative 6. Okay, I just found a common denominator, multiplied the top and the bottom by 2. Okay, now I have 5 minus 14, so we get negative 9 over 2 equals negative 6. So I get, it's getting so messy up here, but we're going to keep going. We're going to get negative 9 equals negative 12, right? Because I multiply both sides by 2. So these cross out, and I get negative 6 times 2 is negative 12 and negative 9. So, wrong. My graph is not great, clearly. Because this point here is not on this line. Okay? So I messed up because of my shitty graph. So how do I actually figure this out? I'm going to show you another way, okay? We're going to do it quickly. Now, I haven't taught this to you yet, but I'm going to tell you. In order to find out where they actually cross, one thing you can do, you can just set the y values to the same, because we know where they cross, where they're actually going to hit, the y value is going to be identical to when they hit. You guys agree with that? Right? This point of intersection, and let's take this line up here, because my line's crappy. This point of intersection, the y value 4 on this line is equal to the y value 4 on this line. Does that make sense?
Yeah.
So one way I can do this then is if I set these two y values the same. So what I'm going to do is I'm just going to substitute this y, this value, and this is called substitution, in for this y and solve for x. All right, so let's do that right here. Watch this. Watch what I do here. Okay, I'm going to say 2x plus 7 is equal to 0.5x plus 4. Everyone understand why I did this? You need to understand why I did it before you can understand how to
I thought
solve
you
it.
were subbing in the y intercept for the y on the.
No. I'm subbing in the equation, the whole equation for the line of y into the other equation. What I'm actually doing is I'm setting the two y equals the same. I'm saying when both y values are the same, what's my x value? And then I can solve for x, and then I can use that x and solve for y.
Oh,
And I'll get the point. You guys get the point? All right, here we go. So we're going to do 2x minus 0.5 x equals 4 minus 7. See how this like terms and this gathering stuff and moving things around? I have to know it. I'm not teaching it again. You got to already know this. If not, you could know exactly what to do, but because you don't have the skills from grade 9, you can't even do it. So we're going to keep going here. We got 2 minus a half. That gives me 1.5. X is equal to negative 3. Okay? And then we have x is equal to negative 2. And I know that because I divide both by 1.5 by 1.5. These cross out. And I get 3 divided by 1.5 is 2. I have the negative. So x is equal to negative 2. All right? Well, if x is equal to negative 2, I can take that value and sub it into either this one or this one. Let's work with this one because it doesn't have a decimal. So I'm going to say y equals 2. X I'm subbing in, negative 2 plus 7. So we get y is equal to negative 4 plus 7. We get y is equal to 3. So my point of intersection, or the solution to where these lines intersect, is what, Josiah?
Negative 2 and 3.
Yeah, perfect. Point of intersection slash solution of linear system, that's what it's called, solution of linear system, is equal to negative 2, 3. That's it. So where did I mess up on my graph? Let's take a look. I said it was negative 3, 5 over 2. So I said it was negative 3, 2.5. I was very off. Well, I was off by, yeah, pretty bad. Let's see if I use a ruler. Let's see how much better I could have done.
sir.
Yep.
Would substitution be like a safer and easier way?
Safer and easier?
Safer way.
Oh, yeah, like to get an exact answer?
Yeah.
Yeah, definitely. Yeah, I hate graphing because you got to be so neat, right? But so you got to know how to do both. To be honest with you, you got to know how to do both. And if you have a ruler, it shouldn't be a big deal. You'll see here. I should get it right on now. Let's see. There's my 2 points. Watch this. If I use a ruler and I cross right through the 2 points, which were here and here. Okay. And we're going to cross through. I was pretty sloppy, not going to lie. Ooh, so close. Very, very close now. Let's see. Look at that. That's right there is negative 2, 3. See how close I was? Pretty good, right? I mean, if you had only graphed and you had to guess a point, that's going to be the point, negative 2, 3. There's no question, right? If you're picking whole numbers. Agreed? Any questions with that one? It was good that I got it wrong because you got to see sort of both equations. So it says check your solution in both equations. Now, I told you that I have not taught you substitution yet. So it doesn't mean by substitution to check. That's how we ended up checking over here. What does it mean when it says check your solution? Yeah, in both equations.
Sorry?
Yeah, go ahead.
Oh, you point the POI into the X and Y values on a line.
Perfect. Yep, that's exactly right. So let's go ahead and do that. We determined from this graph, we can see it here, it's negative 2, 3. So our POI is equal to negative 2, 3. Okay, we're going to sub that into both our equations. And y equals 0.5x plus 4. So we're going to sub that into here. So here's what we get. 3 equals 2, negative 2 plus 7. And 3 equals 0.5, negative 2 plus 4. Okay, we get 3 equals negative 4 plus 7. We get 3 equals 3. 3 equals negative 1 plus 4. 3 equals 3. Oh yeah. That's how you check without substitution. You take the x, you take the y, you plug them back into the original equations. Got it? Any questions? Rudy, why did we do this? Rudy, why did we take this point and plug it back into these? Why did we do this? Why did I take this point and plug it back into this and this? What was the point of that?
Like how you do with the graph.
Sorry?
When you're plugging the points in the graph, you have to make sure it was right. So you have to do the first step beyond that.
Yeah, I had to make sure it was right. I was checking it, right? And what happens if both sides are equal? What does it tell us?
That's right.
Yeah, that point is on the line. Yeah, I know it sounds like I'm asking stupid questions. What I'm actually doing is I'm reinforcing your brain into why we're doing these things, right? Because now when you go to try and do it yourself, you're gonna be like, what did you do after that? Why did you do that? Right? It's just a process of reinforcement. So don't think I'm just like, trying to test you. I'm trying to reinforce why we're doing these things. Okay. I gotta go. We gotta move a bit quicker. Let's go. Example 10. Find the point of intersection. We got two lines here. All right. We need to first graph them, and I'm gonna graph them really well up here because I don't want to do the algebra because I'm lazy. So we're going to graph them well here, but someone has to tell me how to graph them. Who wants to tackle this whole problem by themselves? All right, Chenier, you're going to do it. All right? So what's the first step? How do I graph this? What point should I start on, Chenier? Say it again. 2? Right here? 2? What is 2?
That's the X one.
No. Chenier, come on, man.